Okay, once again, good evening to everyone, and you're welcome to the 10th session, approximately the 10th. So today marks the day where we have covered 1/3 or the first the whole program for the first month. And yeah, so basically we are starting with chapter 5 today. Really wanted that you all should be present because chapter 5 is one of those chapters wherein you learn a lot of real world skills that you're going to apply. So just before we do that, has anyone reached chapter 5 within the Lapsing platform? Has anyone reached chapter 5? Nobody? All right, that's fine. You're definitely going to get there. Just try working with a calm head all the time and do your best to cover the whole material within the time frame of the training. You have the licenses available to you and every other resources that I believe you need to complete this whole module. Chapter 5 is about storage devices. Just before we talk about storage devices, while going through or as we covered the session of last week, does anyone have a question from that week? Like, do you have any worry from what we covered within for last week? Always remember, you can always reply to questions or say suggestions by reacting, raising your hand, by sending emojis. You must not always be silent because I know at times you can't unmute yourself because you know you don't want maybe your background noise to enter the meeting. So what you can instead do is always use reactions. Make it a habit to use reactions. It doesn't matter what kind it is. If I ask a question and you have an answer, you can do thumbs up or you can even raise your hand just to, and yeah, that's it. So we're going to begin right away. We begin with chapter 5, 1.1, and we're going to be talking about storage devices. Some of the key terms that we're going to look at within this chapter or this module are flash memory, hard disk, integrated drive electronics, non-volatile memory express, optical disk, M.2, SD card, solid state, and the solid state drive. So right now, upon the definition, when we look upon the definitions of these various terms, they are going to throw a little more light on what the terms are and which scenarios they are being used in. Don't worry, we're going to define them. So starting with the flash memory, Zidane, help us read the first three. Just take your time and read the first three lines, the first three definitions, sorry.
Okay, sir. We have flash memory, electronic non-volatile memory that is easy to erase and reprogram. Hard disk, a long-term storage device that uses a thick magnetic disk made of silver aluminum platters in a protective shell. Integrated device electronic. An electronic interface that allows communication between yes, sir.
Okay, wait a minute. Just before you read that, the third one, let me first of all explain this first two. The flash memory, your network seems to have issues with your network. The flash memory is an electronic non-volatile memory that is easy to erase and reprogram. Within non-volatile memories, we have several categories, such as EEPROM, EEPROM, and PROM itself. So they all stand for electrically erasable read-only memory, electrically programmable read-only memory, and programmable read-only memory. Now, when you hear about non-volatile memory, it simply is that type of memory that can store its content even when power goes away and you resume from where you left off when you have power back. So the reason why a flash drive is referred to as a non-volatile memory is because it is it's a storage medium that you can easily put in your data in them erase as you want, reprogram it, and give it different purposes on the go, the way you like, without having any loss without having to lose the device in general. So that's why we refer to it as a flash. We refer to the flash memory as a non-volatile memory. So next we have the hard disk drive. It's a long-term storage device that uses a thick magnetic disk made of several aluminum platters in a protective shell. The hard disk drive then is a type of storage device, right? In general, that uses magnetic fields to store, to write, and read data. The process of reading and writing means like saving and how will I say, saving and reading in general. So there are some arms within the metallic shield, the protective aluminum protective shield that protects the whole disk platters that are inside, which are used to store data, with an arm that moves and emits magnetic fields between the disk and the arm's tip to read and write data on the disk in general. So this is what it looks. We're going to see what it looks like in the next slides. Next is an integrated drive electronics. It is an electronic interface that allows communication between a motherboard data pads or bus and a computer's hard disk. The IDE cable is it used to be a type of connector that was used to connect hard disk drives with the motherboard. So the truth is, you're not really going to see it anymore these days unless you get to interact with an institution that is using really, really old electronic components. Next is the non-volatile memory express. It is the most you're going to see these days. It's a memory storage that is designed to allow access to non-volatile storage media through a PCI Express bus. So you all remember that we talked about the PCI Express, about the PCI port or the expansion slots of a PC. And I believe why saying that it was in chapter 3, we talked about the fact that those are ports that we use to add additional functionality to our computer. So imagine you having been able to connect your drives to a SATA port, like connect hard drives, SSD, HDD, optical drives to the various, to the SATA connectors of your machine. But then you need to expand more storage, but you don't have any other place to do that. What you can do is by implementing an NVMe drive on the PCI slot. So the PCI Express, the mini one, I think it's in chapter 3. We saw that if you go through the previous recordings, you're going to see that in chapter 3, we saw the PCI Express port, which is simply the smaller version or the miniaturized form of the PCI port, all of which are expansion slots. Next, we talk about optical disk. That's simply a storage device that records binary information through bits in a reflective coated disk. Optical disk use lasers for reading and writing information. Within optical disk is just a category, and it is not a specific type of disk. Within that domain, we have CDs, we have DVDs, and we even have Blu-ray discs, all of which differ from one another in terms of their criteria. We are going to also look at all of these within the upcoming slides. Next, M.2 is also a popular solid-state drive, often used in portable computing devices. Same as you have an NVMe, which is a solid-state drive, they just differ in the way they are being implemented. Basically, they are all solid-state drives, which means that instead of using any mechanical part like disk platters or magnetic fields to read and write data, they simply have chips in them. The same kind of chips that you find in your flash drives, all of them are solid-state drives. So they use chips to store data, and it is very portable. The one difference now between an M.2 and an NVMe drive is that you use an NVMe to expand storage within your computer by connecting it to the PCIe slot or an expansion slot, whereas the M.2 is just a popular type of solid-state drive that we use in portable computing devices. What do we mean by portable computing devices? We are talking about things like smartphones, tablets, laptops, etc. The next term here we have is an SD card. It is simply a flash memory device that is often used in digital cameras. I believe all of us have seen SD cards. Some of them can even be used in some particular types of phones or even in computers. Last but not the least, we're talking solid-state drive, SSD. a flash disk with this is a flash device with a large storage capacity comparable to a hard disk. So basically, you find a smaller piece of storage media with higher capacity, with higher storage capacity as compared to hard disk drives. So the abbreviation for solid state drive is SSD, whereas the abbreviation for hard disk drive is HDD. We can look on within the upcoming sessions about the differences that exist between solid state drives and the hard disk drives. So there's a task that is for you guys to do is to look at the differences between SSD and HDD. Zidane, go ahead. What's your question?
Yes, sir. What's an example of an M.2, sir?
What is that?
M.2 in the previous, before you finish explaining, sir, an M.2 storage device.
What do you need? You need an example?
Yes, sir.
An M.2 is simply a particular category, right, of storage devices like miniature SSD, sorry, like they are miniaturized form of solid state drives that can be implemented in portable devices. So it's like you have to have the same storage that you have in your laptop. You need to, if you have it also in a smartphone, they definitely should be in a different size, which means that if I have like an NVMe inside a laptop, which is kind of big, or inside a CPU, I need to also have an SSD also inside my phone. But how do I implement that? You're not going to carry a big NVMe or another SSD, a big SSD drive itself, and put inside a small smartphone. What you use is use the miniature kind. So that category of SSDs, which is relatively small and used in portable devices, is what we refer to as the M.2. So basically, M.2 is a category, and it now comes manufactured by several different manufacturers. What we're going to do right now is to just quickly switch. We're going to quickly switch to the web and do a search. We're going to do a web search, excuse me, and you see all M.2 drives. Just 1 second. Okay. All right. Here we go. I believe you all can see the screen. So we're just going to look at M.2 SSD drives. So basically, you just see them. They are really, really small chips. Let's go on Amazon and see them. Amazon is always going to show them better. Sorry if Amazon is taking so long. So SATA SSD and NVMe. M.2. Sorry. That result is not available at the moment. We're going to get back to it. Just please have it in mind. We're going to get back to this. Okay. That being said, let's look at the structure of a hard disk drive. We have this particular disk, like this is what we see inside a hard disk drive normally. There is this arm that moves left and right, forward and backward, and covers the whole disk. Like when it goes forward, it covers to this angle. When it comes backward, it covers to this other end. And while the disk is spinning, it is capable of reading data on all parts of this disk using electromagnetic waves. You can see right now that we have like 1, 2, 3 arms, and they are all they are intertwined within 3 different disks. So you find yourself now with these 3 disks that can all spin in the computer and data being read on them and written concurrently, which means all at the same time. So these are the platers, right? These are the platers in an HDD, and this is the armature or the arm with these heads that are used to read and write. They just simply emit electromagnetic waves that capture data on the drives using a particular type of effect, which is referred to as the Bernoulli effect. So if you read about the Bernoulli effect, if you ever hear about the Bernoulli effect, it is simply that effect that is described or explained when these headers here, these read-write heads on an armature of a hard disk drive is reading data on the plater using electromagnetic wave. This is a more realistic representation of what an HDD looks like from the inside. So we categorize the rotations of hard disk drives according to their speeds, according to the rotation speeds. So if you look at the abbreviation that says RPM, that simply means rotation per minute. So the faster, just remember that the more rotations per minute you have, the faster the hard disk drive is going to be able to read and write data. So you have 5,400 being the lowest RPM of a hard disk drive and 15,000 RPM being the fastest speed of an hard disk drive. So some of the disadvantages you have with the hard disk drive is that it's not very portable, which means it generally needs a lot of electricity and it is difficult to implement while working around with. Mostly hard disk drives are always installed inside the computer, so it is difficult to use it from the outside, except for some rare scenarios or in updated versions. Like you cannot really find a hard disk drive that uses an IDE connector like this particular hard disk. You cannot find that kind of a hard disk, this particular one being used as an external drive. Okay, so basically it is just inside the computer as well. Now the USB interface is large, which means that it is not it has a very broad variety of a USB interface, and it cannot easily be implemented on the go. The next type of storage device that we're going to look at is a solid state drive. So basically, under storage devices, we have already covered hard disk drives, and now we are looking at a solid state drive. Same as the hard disk drive, this is just another type of drive, which instead of being made of magnetic disk and with an armature and all the read-write heads that are having moving parts, we simply have a very flat disk with chips inside that are used to store data. So these chips are what you can see there like an X-ray of the disk displaying the internal components of this solid state drive. Those are chips. All those chips are used to store data. So they are being implemented in tablets, mobile phones, computers, and laptops, and even other types of smartphones. So now we're looking at some type of storage devices, all right? Some type of the solid state drives. Right now you have the M.2 solid state drive, which is basically comes in 2 variations depending on the manufacturer. So your manufacturer is the person that determines what your drive should look like, but basically they always have the same connectors, and that should be it. So you see right here at the bottom is a 500 gigabyte M.2 SSD, whereas the one at the top is a 250 the gigabyte M.2 SSD. So the next type of solid state drive, or the next type of SSD is the NVMe, which can be implemented using the PCIe port of a computer. So right now, this particular SSD is manufactured by Samsung Electronics, and it is a terabyte. Just imagine yourself having this small chip here that is at 1 terabyte. So basically 1,024 gigabytes compared to this particular one here, which could just be Like the whole bunch of this could just be like 250 gigabyte, and to the highest point, maybe 1 terabyte, and it is very rare. It is very rare to find that. The next type of storage device that we're going to look at here is a flash drive. It's basically also just an EEPROM, an electrically erasable programmable read-only memory. So it also has a chip in it, which is very portable and can be plugged in and can be communicated. Data can be communicated with the chip to and fro using a USB interface. So you basically just plug it into any device that accesses the USB Type A interface, and you're good to go. The next storage device here is a flash memory device or an SD card. It is a type of memory that is used in digital cameras and storage device that permits you to easily transfer files from like your computer, from your camera to your computer without having any glitch. So some very advantages of or characteristics of flash memories are that they are very portable, they are fast and have large storage capacity, and they are actually very small in terms of their physical size. Next, we have optical disk drives as storage device. It is just a category of storage devices because that refers to some storage devices that are circular with a reflective surface, which uses where lasers are being used to read and write data to and from the disk. The advantages of this type of drive is that it is portable, it has good storage capacity, and it is a great means to implement long-term storage. Summarily, we have talked about hard disk drives and solid-state drives, as well as portable drives such as flash device and optical media. Now we are going to talk about storage devices, how to look at the practical aspect 5.5 under the next submodule of chapter 5. We're going to look at the SATA module, which is basically letting us know how we can install SATA devices. SATA devices, what do we mean by SATA? Someone should please, if you know what SATA is, raise your hand. Raise your hand to give us a definition of SATA. What does SATA stand for?
Serial Advanced Technology Attachment.
Okay, serial advanced technology. And what is it? And what is it? What is serial advanced technology attachment? What is SATA? Okay.
So SATA is a type of hard drive, sir. Yes, sir.
Come again. Can you say that again?
SATA is a type of hard drive. I said SATA is a type of... Yes, sir.
No, SATA is not a type of hard drive. SATA is a technology that is used to attach hard drives or storage devices alongside other type of external devices to your motherboard. It is not a storage medium. It is simply an attachment technology.
Okay, sir.
So yes. So it is. Go ahead, ask your question.
So the type of storage being embedded in Android phone use, which type of storage, sir? The kind of storage you have in Android phones?
Generally, that's M.2 drives. SSDs. Okay. The kind of, sorry, let me answer. It is a SSDs. We have SSDs.
Okay, sir.
Any other question?
No, sir, it's fine.
Okay. So the key definition, some of the key definitions that we have here is just going to break down what SATA is and what eSATA is. So SATA stands for Serial Advanced Technology Attachment, and it is the largest generation of standards for hard disk drives and other storage devices. So it's simply a standard that is used to connect hard disk drives and other storage devices to the motherboard, as I said previously. eSATA is just the E there just adds external to SATA, and it's an extension to the SATA standard that enables SATA drives to be connected, to be attached externally to the computer. So you find yourself now being able to use solid-state drives and other types of drive storage medium from outside the computer without necessarily having to put them inside. So SATA works with hard disk drives, solid-state drives, and optical drives. I believe you all should have seen external drives these days, some of which make noise and others that don't, as well as external optical disk readers that can be plugged into your computer. They use the SATA technology to connect these particular storage devices to your computer. So you basically have this is what a SATA cable looks like. A SATA cable, and it has two main channels, each divided into two, that both send and receive data via 7 pins on the connector, right? So this cable has 7 pins that are used to connect, that is used to transfer data from the to and fro the PC. This is physically what a SATA cable looks like. They are generally having the names written on it here, that's SATA, and it is having this, how will I say, there's this signature red. I don't know if this is ox blood or, well, you guys should be the color specialist, but this is generally what a SATA cable looks like. If you notice, everywhere it is always that way. Well, the SATA connector itself is an L-shaped connector. I believe we have discussed about this particular type of connector previously. We thought about it to be an L-shaped connector, which prevents it to be plugged in the wrong direction. So the reason why you have that connector shaped there as an L is so that even if no matter how hard you try, you cannot break your port or insert it in the wrong way, you necessarily always have to look and insert it in the correct direction, which is the direction of the L. So the SATA power, the two SATA connectors that we have are the SATA for the data channel and the SATA for power. The first one is the 7-pin connector, and the second one is the 15-pin SATA connector. The one for the 7-pin connector is that which provides data transfer, whereas the one to the right provides just power and electricity. It has 4 main cables that bring in power into the computer. Now, the interfaces where this is what the SATA interface on the motherboard looks like, where you can plug in your SATA cables. You see the SATA cable here. When you plug one end like this to a solid-state drive, to any type of storage drive, the device, this is the other part that you bring and connect to. This is where you connect the other end to the motherboard. That's what it looks like. So the one advantage about SATA drives is that there are hot pluggable or hot swappable, which means you can connect them and disconnect them as you like while the system is running. SATA now comes in several generations, all right? Several generations that also embody different characteristics. The SATA 1 is the first generation, or the original SATA revision, that transmits data at 1.5 gigabytes per second. The SATA 2 is the next generation of SATA that could transfer data at 3 gigabytes per second, right? And it used the native command queuing. So that's the additional feature that it had from the previous versions. You have to remember that when we say this one has these features, it doesn't mean that it does not have the previous one. It is just an upgrade, which means it has additional features to the ones that were already existent. The SATA 3 could transfer data at 6 gigabytes per second, and it is used with high performance HDDs and solid-state drives. So SATA 3 is what is mostly implemented in external hard disk drives, as we call it, disk external hard disk. And it is also made to be able to work with newer connectors, such as even the USB. So the next generation of SATA is the eSATA, or external SATA, that connects external SATA drives faster than USB or even the FireWire. The eSATA has this characteristic 2 edges here, 2 locking clips that permit it to lock the external SATA drive to the connectors to prevent it from shaking, because the SATA standard the SATA port on its own is not a very, very strong one. which so it needs extra the eSATA technology that permits us to use the SATA out from externally provides a locking clip that will seal the connector or the to the port, right? So basically that's it. Now, one thing you should also have figured out by now is that the SATA connector only transfers data. It doesn't provide means for us to transfer power. So that lack of power now has made it in a way where you see inside the drive, we have here a scenario implemented where you have to connect the SATA cable for data, and then you connect the 15-pin cable for power. Now, what if we need to use this now externally on a hard disk drive, as we just said? It is a scenario where we find ourselves having to like block the cellular device first of all to current before plugging the data cable. But who wants to plug two cables to a computer, to a device externally? Nobody wants that. So basically what is done is that the next standard of SATA comes up, of eSATA comes up, which is the eSATA P. The P at the end there simply stands for power. So it both combines eSATA, USB, and power at the same time. The power level of this technology, the eSATA P, is of 5 and 12 volts. So the data and power integrated, data and power are all integrated within a single cable. So instead of having a single cable like this one that only transmits data, now this new SATA with eSATA P, you're capable of transmitting both power and data at the same time. So to implement the SATA devices, we check the SATA standard, the component and the port, and then work with the standards that are matching. So summarily, we have talked about the SATA interfaces, the SATA cables, and the various revisions or generations of SATA, as well as connecting SATA devices to the various devices that are matching. So what you have to do what you'll be doing within the lab is to install the SATA device. Okay, you're going to install the SATA device. Now we have reached the next model, which is 5.3, and it is optical media. Just before we begin, do we have any questions? Just raise your hand if you have a question. Will it take a few seconds to listen to that, to listen to those? If you have any question, just raise your hand. Okay, go ahead.
Yes, sir. The eSATA, sir, is the same technology they use to like convert. Let me say, like when you buy an external hard drive, those connectors inside to produce the USB that we have outside is the same technology, that's why, because it's similar.
Okay. What I want you to understand is that because the coming of the USB technology has solved a lot of problems. It is because there was no USB that you saw all these various type of connectors being created. If we even have the IDE, the SATA, the display, and all the other types of connectors and ports, it is because there was no unified or like a standard, there was like no standard to develop the connectors within a PC. So the USB that you see these days is now capable of adapting to any kind of technology, so long as it comes with ports. Okay, so that's why you find yourself now not really implementing the SATA cables externally, but they were used. It's just that we don't find ourselves in the right generation. There was a time where SATA cables will be used externally. All these cables that you're seeing we're talking about here, they were actually used to connect drives externally. It just happened that within these times, the USB has shaken the whole market, and every single technology is almost connected using just the USB. So it is a more unified technology that has come to help us, save us the stress from having to use every single connector or technology that we use out there to transfer data from my devices and provide power as well. USB does that all. I've answered your question.
Yes, sir.
Any other person with a question? Just raise your hand if you have a question. Okay. I think I'll ask a question. Okay. Mazule, can you hear us?
Yes, sir. I can get you.
Okay. Okay, I have a question for you. The question is, what's the difference between eSATA P and USB?
The difference between eSATA P and the USB is that eSATA P transfers both the data and is responsible for power supply too, while the USB transfers just data.
Are you sure?
Yes, sir.
You're sure that USB transfers only data?
Yes, sir.
Do you charge your phone with a USB?
Yes, sir.
I believe you know. I want to
So
make sure that you understand. I want
means
to make
the
sure that you understand that you. Hello, just
yes, sir.
listen to this. I
Okay.
want to make sure that you understand the difference. I want to make sure that you understand that USB comes in several generations and several versions. So the one that the one that you use to charge regular Android phones is referred to as the micro USB. We have the mini USB-B, which is used to connect printers and projectors. We have the USB Type-C, which is used these days for basically every other thing. And there is the USB Type-A, which is the general one that you find on your computers, which we analyzed as the main connector for flash drives. So those are just different, there are just different variations, mini USB, micro USB, USB Type-C, USB Type-A, all of them are just various variations of the USB technology. So you want to, from what you said, from the, I actually asked for difference, but you said that the eSATA P provides power and data transfer, whereas USB provides only, what did you say USB provides? Only data transfer. Is that what you said? What did you say? What did you say USB does?
So I said it provides just data transmission.
Okay. The one question I have is, I believe that the phone you use should be able to is charged using a USB, any version of a USB device, right? Of the USB technology. You should be using either
Yes,
Type-C or micro USB. You use it to, you find out that
yes, sir.
you're able to charge your phone and transmit data at the same time. So that does not make it a difference between eSATA P and USB. That's not a difference.
Oh, okay. So I thought you meant the USB key.
What happened? What about the USB key?
No, sir, I thought you were asking the difference between the USB key and the eSATA P cables.
No, USB key is not even a thing. We say a flash drive. Understand where your confusion is coming from. We don't even say USB is not even it's not a device. It is a technology. Do you
Okay,
get
sir.
me? So
Yes, sir.
I get where your confusion is coming from. I just want that from today. You should not do that. You should not say this. You should be able to go out there and make the difference when you speak. Have it in mind that USB is not a device. If you want to ask for like someone's storage device that uses the USB technology, you should say the flash drive, your flash drive, or just give me your storage device. That's simple. But generally, what you refer to as USB, what we refer to you as USB locally is it's a flash drive. So when I said USB versus eSATA P, I was just meaning the technology, not the actual devices. That's what I was wanting to get a difference. Okay. So one difference is that the eSATA P needs a securing clip, but the USB does not. Do you need a securing clip in the USB to like hang to make the USB being hooked
Okay, sir.
to the connector it's connected to? When you plug a USB to a computer, is there an extra clip that holds the computer to secure it in?
No.
Yes, so that's the difference between USB and eSATA-P. Aside from that, they basically do the same thing. And another difference is just that they are different in standard. They are just different standards. That's just it. They are different standards, and they don't the difference in the lack of clips, securing clips in USB versus eSATA-P. I want to believe that. Oh, Mazule. I want to believe that you've understood, Mazule.
So I did not
say
get you.
much.
My network is.
Yeah. Okay, let me take it all over. I'm just saying that you have to understand that there's the difference between eSATA-P. eSATA-P and USB is just from the point of one of them having a clip that holds the connector to the port where it is being connected, and that they are just different standards. So the difference in standards or technologies and the difference in the securing clip is what makes, that's the only thing that really differentiates them. Other than that, eSATA-P and USB, they practically have a lot of things in common. Remember,
Okay.
yes, remember, USB is just a technology. USB is not a device. Don't say, give me your USB, help me with your USB. Where is my USB? Rather say, where is my flash drive? All right. Or you could even say my USB drive, but it is preferable to always say flash drive because USB is just a technology. You should make the difference.
Okay,
Go
sir.
out there. Yes. Go out there and make the difference. I believe you guys have learned something today. So is there any other question? Is there any other question?
So I wanted to ask about the Bernoulli effect.
The Bernoulli effect. The Bernoulli effect, right? Can you hear me? Seems
Yes,
like
sir.
she's having issues. Seems like she's having issues connecting. I'm going to get back to the Bernoulli effect shortly. Okay, so right now we are looking at optical media, the form of storage devices, this type of storage devices that use a reflective coating on the surface alongside laser lights to read and write data. So the key terms we're going to be using here is optical drive, optical media, compact disc or CD, digital versatile disc, DVD, or Blu-ray disc, BD. What is an optical drive? This is simply a drive that uses laser lights or electromagnetic waves within or near the visible light spectrum as far as part of the process of reading or writing data to or from optical disc. An optical media, on the other hand, is a flat circular disc used to store large amounts of data. CD, a compact disc, is a digital optical disc that with data storage format that has the capacity. Sorry. Compact disc is a digital optical disc data storage format with data capacity of 700 megabytes. Whereas digital versatile disc stands for DVD. DVD stands for digital versatile disc, and it's an optical media standard that can be used to store large amounts of different types of data, such as computer data, video, and audio. And this particular format can store, I think, a maximum of 4.7 gigabytes of data. So DVD, while CDs can only store 700 megabytes maximum data, the DVD technologies can store up to 4.7 gigabytes of data. The next is the Blu-ray disc format, which is a new digital optical disc storage format that is capable of storing even greater, of having even a greater storage capacity than DVD drives. So let's look at CD drives. A CD can hold 74 to 80 minutes of audio. It has a diameter of 120 millimeters and it is 1.2 millimeter thick. Those are the dimensions of a CD. A CD-ROM, on the other hand, or compact disk read-only memory, like CD-ROM, the RO there stands for read-only memory, has 737 megabytes with error correction. It has 8,947 megabytes in total. It can read 150 kilobytes per second. Okay, so one drive is equal to 150 kilobytes per second. Two drives will be 300 kilobytes per second, and so on. So the CD RW, you're going to see that those attributes at the end, RW, ROM, W, or R, they all mean something. When you see CD RW, it stands for compact disk rewritable. That has a capacity of 650 megabytes. It's a removable disk that where you can. Yes, George, go on.
Lisa, you said the CD-ROM only takes only 8,000 something. So, but there are these CD-ROMs that they will sell with movies. You just take like a season of movies, which is more than that. If the capacity of the movie is more than this 8,947. How come, sir?
I want to believe that the question comes from the. Sorry. I want to believe that the question comes from the point where you buy CDs with a lot of movies already inside them, and you cannot tell their size. You cannot tell their size because there are a lot of movies inside. It doesn't match up with the amount that we're saying here. Remember, I said the CD on its own can store just for 700 megabytes worth of stuff of data. Back in the days when data was not of really high quality, a very small amount of data, large amount of data can actually can use a very small amount of space. And remember that before all this data being stored on these devices, they are compressed to an extremely high level. They are compressed and only decompressed when they are being read. So you can have like a 15 gigabyte file being stored as a 3 gigabyte just for storage, and it is only expanded to its initial size when it is being read. So I believe that you know about compressing and using software like WinZip, WinRAR, and all the others, wherein you can really reduce the size of big files. So the technology of compression that you find there can also be implemented in these drives, but just have in mind that 700 megabytes is the capacity of CDs. CD-ROMs have their own, and every other technology of CD have their own capacity. If you look well, when you buy those CDs and actually look on it, if you find a CD that has a lot of movies, a lot of them have their label written on them as well as their storage capacity. So let's look at I believe that question is being answered, or do you have any other worry?
No, sir.
Okay. Next is a CD-RW. CD, which stands for compact disk rewritable. It has a capacity of 650 megabytes, and it's a removable disk, which means it can we can also burn, erase, and read, which means when we write data onto the CD, we can remove it, we can wipe it completely, and then write another thing inside, all right, and read from it as well. So the drive speed rating is when we are rating the drive's rating, we have to read it according to the write speed, the rewrite speed, and even the read speed. The CD-ROM, this is what the CD-ROM actually looks like. The bits that you find there don't reflect, and the LAN does reflect. So it is the difference in the bits and the LANs that is being reflected by the laser that make up the bits, the binary code of transmitted from the disk, zeros and ones, that is then compiled by the computer to make up data. What am I saying? The difference in space between bits and LANs on the surface of a CD is what is being reflected by the laser beam that is used to read data from the CD. And when the data is being, when the reflective surface retransmits the reflection from the laser, it then provides information about the positioning of the various bits and zeros and ones within the drive as well. So you find that maybe the pit does not reflect, it means a 0. The layer that reflects maybe means a 1. So it then makes up a combination of zeros and ones, which can then be compiled and converted into data by the computer. That's basically how it does. So you find yourself here using a laser. The laser then reflects on the CG as it is spinning. So when it meets a reflective layer, the reflective layer reflects the data to this photosensitive device and it records it as a 0. When it, it records it as a 1, and when it stops reflecting, it records as a 0. So the whole combination of zeros and ones, as you can see here, that there's a gap, a long gap between this pit and the LAN. This pit and the other pit, there's a long distance, so that can be a lot of ones or a lot of zeros, depending on which algorithm is being used. So that's how data is being read from CD drives. So photosensitive crystalline coating. So the CDRW this is how the CDRW read-write surface looks like. It has an extra layer of crystalline coating that reacts to the laser and then provides the amount of data, the data that you need. But it is due to a technology that we refer to as phase shifting that permits us to read read, write, erase, and rewrite another data on CDRW. So summarily, we have discussed the CD storage, the CD-ROM, and the CDRW. Now let's discuss DVD, digital versatile disk, or digital video disk. It is this kind of storage devices that provide storage for video, audio, and other forms of data. So generally, when you were talking about, I think George was talking about buying CDs that can store over 700 megabytes. What you generally buy is DVD, okay? You buy DVD or VCD even sometimes. DVD has a storage capacity of 4.7 gigabyte, as I said previously. And if not for the purpose of compression, that amount of movie cannot enter in a CD. So if you find a CD that has a lot of movies, definitely that should be a DVD. So as you can see here, that is a DVD, that is a CD. CD has 737 megabytes in capacity, so while the DVD has 4.7 gigabyte. Take note, if you need to ever buy any of these, look at what you're trying to buy. Don't go for cheap. Always really inquire. And I believe after the class of today, you should be able to know exactly which is which and what you should get. Now when we're talking about DVD-ROM, it has 4.7 gigabytes of capacity, and it is all read-only memory, which means when you write data onto it once, you can only read it. You will not be able to rewrite it anymore. You just write data to it once. That's what we stand for. That's where DVD-ROM falls. So the drive speed for one drive, you have 11 megabytes per second, 2 22 megabytes per second, and so on and so forth. The DVD-RW, on the other hand, also has 4.7 gigabytes of capacity, same as DVD-ROM, but it has read-write capabilities, which means you can wipe data from it and rewrite it as you want. It is very portable and also has a crystalline encoding, but it has a limited lifetime. That's the problem. Now, the dual layer, there are DVDs that have dual layers, which can provide up to 8.5 gigabytes in capacity. They are backward compatible, which means that they can work with previous technology readers that DVD readers, that optical drives that can read previous technology. Irrespective of the generation of optical drives, the dual layer DVD will work on them. So there is opposition trackpad, which is a term that we can all look up. We can take time to look that up. Opposition trackpad. I'm not very sure of what that stands for right now. So, but this generally has a slower write speed as compared to the other technologies because it has a dual layer. So the slight layer change delay. So by the time you're changing delay, you're changing layer from the first to the second. That delay causes you to have a slower read and write time, as compared to the other versions of DVD. Right, as of right now, we have finished with that module, and we have talked about the digital video disc, which is the DVD, the data storage and DVD room, DVD read-write, rewritable, and dual layer. Now we are looking at Blu-ray. What is Blu-ray? Blu-ray is a type of disc also that has several higher storage capacities as compared to the other versions of CDs. So we find ourselves with CDs that as well. I'm still going to address the fact that George brought up a question that was where he was talking about having seen CDs with a lot of movies that might be more than 700 and whatsoever megabyte that he called in. As we said, the limit for CDs were 747 megabytes or 700 megabytes. The difference, all of them look the same unless you find a label on them. Some don't even have labels, but unless otherwise told, you will not be able to know what their actual size is. You'll not be able to know what their actual size is. So the Blu-ray disc has 120 millimeters in diameter and 1.2 millimeters, and it's 1.2 millimeters thick, same as every other CD. So there's basically no physical thing that can permit you to distinguish a difference between them. If there's no labeling, you'll not be able to know which one is which. But then we have single layer Blu-ray disc that can store 25 gigabytes. So one CD, one Blu-ray disc or BD can store 25 gigabytes of data. A dual layer own will store 50 gigabytes, while a triple layer will store 100 gigabytes of data. Now, a BD that has quadruple layer, which means 4 layers, will be able to store 128 gigabytes of data. Compare that kind of an optical disc to a compact a CD. Compare this BD to a CD, the quadruple layer BD and a CD. You see that the difference is outrageous, right? Let's do the math. I want us to do the math and look like we say 128 gigabyte times 1024 makes up on 131,000 megabytes. If we do divide it by 747 megabytes, we will see that the quadruple layer Blu-ray disc is 175 times more storage than a regular CD. Isn't that crazy? Masude, do you understand?
Yes, sir.
Yes. So basically, what did you understand?
Yes, so that the Blu-ray disc has the difference between the Blu-ray disc and the DVD. The difference in their storage is very large.
I was comparing with the CD that has 747 megabytes. Yes. So the quadruple layer Blu-ray disc is 175 times more than a regular CD. So you can find a CD, you find a Blu-ray disc can store essentially 175 times more data than a CD. That's what you have to have in mind. So the various formats of Blu-ray that we have BD room, read only. Okay, go ahead, my dear. Go ahead, ask a question.
Yes, when you talk about the single layer and the double layer, does the single layer mean one disc, and then the four layers, does it mean, is it 4 different discs, or that is just one disc compressed?
It is one single disc that is having several layers of coating. Look at this disc. Look at this particular disc here. You see this disc right here? There is a crystalline coating on it that makes one layer. So the intensity of light from the laser is what determines which layer we are reading from. It's like the more intensity, the more layers you're going to be able to read, and that laser can now pass across several layers and read data. So basically, you're just reading across this on the same. Sorry, please unmute yourself. Mute yourself. Sorry. Okay, thank you. Please mute yourself. The person that made the noise. All right, so I was explaining that due to a process of course phase shifting, you can read data on different layers of a CD or an optical disc by well, the technology is complex and it is implemented within the readers. So they just know, I don't really understand how that whole procedure works, but I know that you're reading from different layers that so that definitely just provides more storage. Essentially, it is just the way you see this one here, like 1.2 to 1.2 millimeters in thickness, 120 millimeters in diameter. There's no physical difference. It's just that there are more layers on a single disk. It is not like there's a difference it's like there are two different disks or not. There's just one disk with several layers. I hope I do not confuse you more.
No, sir. No, it's understood, sir.
Okay. So the way you see this crystalline layer on the CDRW, it's the same way the other 4 layers of a Blu-ray disc are being implemented, one on top of the other. I think even if you even look at it from a particular perspective, you will see that maybe they use different kind of material to implement the various layers so that it should react to the different kinds of light in a different way. For example, if I send blue light, it receives data from the second layer. If I send green light, it receives data from the first layer. You get the point, right?
Yes, sir.
Yeah, it reflects. Blue light will only reflect data from this first layer. Yellow light will only reflect data from the third layer. Green light will only reflect data from the first layer. I think that's how that whole procedure works. So that being said, we move to the various formats of Blu-ray. The BD-ROM is where the ROM stands for read-only memory. The BDR, recordable. R stands for recordable. BDRE, rewritable, and Ultra HD Blu-ray, which has improved audio and video. Now, the Blu-ray disc, the red laser is what is generally used to read data on CD and DVD, but it uses a blue laser. So as we said, because of the compactness in the look at how the layers are being compacted. That's why you find yourself where the Blu-ray has its totally different type of laser that reads data from it. I don't know if you guys have to see these DVD readers. We used to call it back in the days deck, my deck, something like that. You find out that the various type of technologies that DVD reader that CD drive reader, the various type of discs that it can read are being mentioned on it. Sometimes you see CD/DVD, sometimes you see Blu-ray and all the kind of stuff. But just know that on a normal CD or DVD reader, a Blu-ray disc will not function. Okay.
Okay.
That being said, yeah. So we also have to adapt ourselves to current trends and upcoming and the current technologies. So few are the people that actually use CDs again these days to store data. Well, I do, but I don't know about you. Nevertheless, you see that the Blu-ray has shorter lengths. The Blu-ray that reads data from Blu-ray disc has shorter lengths, whereas the shorter wavelengths, whereas the red ray has longer wavelengths. All of them play various roles in reading data on Blu-ray disc. Now, the Blu-ray disc in general and the various formats are what we have studied within this sub-module. That brings us to the next section here, which is RAID storage. Let me see where we are to know if you are going to stop here or continue. But we have covered a lot of information. And I want to know if we are going to stop here or continue from there in the next class. Okay. Okay, great. I think we should just before we have to even introduce this next chapter. Okay, we are going to cover the whole RAID module and then just leave file systems. We're going to begin from file systems in the next class on Sunday. We're going to begin from file systems on Sunday. So let's look at RAID. What is RAID? I'll explain to you what RAID is, but what I want you guys to do right now is to ask me questions from what we just did previously. Ask questions. You must have a lot of questions. I need you guys to ask questions. Otherwise, I ask my questions.
Sir, I have a question.
Go ahead.
So the Bernoulli effect. So I did not quite understand it, and I wanted to ask if it's the same effect those olden days, this olden days music discs usually use.
Can you rephrase your question?
I mean, like this in those olden days, there were this particular type of big black disc where they usually play music on. I don't know whether it's the same effect with this other Bernoulli effect. Is it the same effect they use for the hard drive?
Do they use the device you're talking about? Was it used to read drives, or what kind of drives do they use?
That is big black discs that they usually play music on. I don't really know the name. I don't know whether they were.
Yes,
But they had
yes. That's Bernoulli effect. You got it.
okay.
Yes, I know. The player with the very big black CD, right, where you take a pin and just put it on top of it, and the pin is moving across and reading from the dents, it's producing sound, right?
Yes, sir.
There is an arm that is moving across the big black disc that is used to, that's exactly how Bernoulli effect works. But the only difference that we have here is the fact that this one in the hard drive uses electromagnetic waves. It doesn't actually touch. You get it right? Sorry, magnetism.
Yes, sir.
Yeah, that's the only difference.
Okay,
Well,
sir.
I'll be able to tell you more about Bernoulli effect within our next session. Okay, on Sunday I should be able to tell you a lot more on Bernoulli effect. That being said, what is the difference? Any other question from you guys? The silence means no question. Okay.
Yes, sir.
I have one question. Yeah. Do you have a question?
Sir,
Pardon?
yes, sir. I'm having a question. Sir.
Okay. Yeah, go ahead.
Sir, the difference between a DVD disc and a Blu-ray disc, sir.
Okay. The difference between a DVD disc and a Blu-ray disc is mostly in terms of the type of light that is used to read data from them, as well as their size. Okay. You find yourself with a DVD that you can the DVD has a specific limit in terms of storage, and where as compared to the Blu-ray disc, that's just the main difference in terms of storage. The DVD has a shorter lifespan as compared to Blu-ray disc.
Okay, sir.
Okay. Yeah, I might be mixing something up. We're going to come back to that, but definitely just what you have to keep in your mind for now is that Blu-ray disc has more storage capacity than DVD. That's it. The max for Blu-ray, the maximum storage capacity of a Blu-ray disc is 4.7. Sorry, of a DVD is 4.7 gigabytes, and those with double layers can store up to 8.5 gigabytes. That's the maximum. Whereas the storage of a Blu-ray disc or B disc starts from 25 gigabytes for a single layer. For double layers, we go already at 50, 3 layers, 100, and 4 layers, 128 gigabytes. Okay. Have I answered your question?
Yes, sir.
All right. Now let's look at RAID. I want somebody here to tell me what is the meaning of RAID. RAID. It's an acronym that means something.
Wait. Yes, sir.
Go ahead.
So RAID means redundant array of independent disk. Yes, I think so.
You just googled, right? You just googled, right?
No, sir. We read in school.
No, you googled, but you were too slow. You googled, but you were very slow. You should be able, like, see, Google is your friend. As an IT person, Google should be your friend. You should be able to, like, with the click of a finger, go to Google and come back. Google has every answer. I will not really advise you as a learner to really use AI. As a learner, I will not advise you to use AI. I really want, it will be preferred. It's when you maybe you're already in a professional setting. Now you just need to be more efficient. Now you can use AI upon my advice, but in general, just use Google. Google is really nice. It provides you with, right now you just go in a click of a finger, you find an answer. So sorry for that little disruption. What you said is correct. RAID stands for redundant array of independent disk. Now, the skills you're going to learn in this section is how to create a RAID array and how to implement a RAID solution. Just before we start that, I just want to know, we're supposed to be ending in 6 minutes. Are you guys comfortable with us taking like 5 minutes break, because this is a whole new concept that you need to learn? Do you prefer us to take a break and then come back and look at the RAID module, or we start from here when we still have a fresh mind within our next session? What do you prefer? Hey guys, what do you prefer?
Sorry, sir. I didn't get you well, sir.
Okay, I think I'm going to decide. Let's call this a day. The reason being that this is a module that I want you guys to really understand, like from the roots of it. I want you to understand every single thing about it and not have to ever study it again. It's actually very important. It's actually very important, and I believe you've already learned a lot. You have done up to 3 sub-modules. You're about to begin the 4th. We did well. We went really fast today. And let me congratulate those of you who were able to show up. I believe that you learned something new. And as the days go by, you become a little much more of an IT technician. So that being said, study well. Make sure to go through your labs, do them. If you have difficulties, we are always there to help. I really insist on this. If you have any challenge with the lab, we are always available to give you the assistance that you need, okay? So try as much as possible to cover the labs, go through it, and make sure that you can do your best to cover every chapter before we even come here on Saturday for the presentation. Do your best, because every single time it looks like we're talking about something new, whereas there are things that you're expected to have covered already. Okay, so please just do your best, and yeah, let's see how things go. So yeah, one question from Azule.
Yes, sir. Just something small.
Go ahead.
So does the DVD has different layers too, like the Blu-ray disc?
DVD has two, a maximum of two.
Oh, okay.
Yeah, a
So
crystal
what are
coated
what are
layer.
all right. So what
What
are
are they?
the storage differences?
With DVD, with a single layer DVD, you have 4.7 gigabytes, and with a dual layer DVD, you can have up to 8.5 gigabytes. Whereas on the Blu-ray disc, with a single layer, you have 25 gigabytes. With a dual layer, you have 50 gigabytes. With a triple layer, you get 100 gigabytes, and quadruple layer, 128 gigabytes. I've answered your question.
So line please come in.
Right, come again.
Yes, sir.
Okay. Blu-ray DVDs and Blu-ray disc differ in terms of sizes. All right. In terms of according to they are one of the only CD drives that can host that can have several layers. The DVD can have a maximum of 2 layers, where a single layer DVD will provide 4.7 gigabytes of maximum storage, and a dual layer DVD will provide a maximum of 8.5 gigabytes of storage. On the other hand, we have Blu-ray disc, whose minimum storage for a single layer, whose maximum storage for a single layer is 25 gigabytes. Whereas the dual layer Blu-ray is 50 gigabytes, triple layer Blu-ray is 100 gigabytes, and the quadruple layer DVD Blu-ray, is 128 gigabytes.
All right, thank you, sir.
Okay. Do you have any other question?
No, sir, that's all for now.
Okay. Okay, let me take another question. Let me take another question again. One more question. Okay. So that being said, Mazule, have you been going through, what chapter are you in right now?
I've just been glancing through chapter 3.
Oh, okay, you're through chapter 3 right now.
You mean on the lab now, sir?
Yes, on the labs.
Yes, sir.
Okay. All right, that's okay. That's fine. Just keep going. If you face any challenges with the platform, if you have difficulties, you can always get back to us. To me
Yes, sir.
particularly, get back to me particularly if you're whoever you're comfortable with. The team is available, so you're.
All right, sir.
Okay. So I guess that should
Sir,
be
one
it.
last question.
Yes, go ahead.
So I've been reading about plenum cables. I don't know if you can give me your own explanation for them.
Reading about
Plenum cables. Let me just take it back.
plenum cables.
Plenum cables.
Let me plenum is first of all a particular technology that describes plenum is a word that describes a particular space within the ventilation area of a building. Now, plenum cable is the type of cable that can work within that environment such that it is like immune to fire outbreaks, for instance. So like the fire catches within the ventilation area of a building, and the plenum cables will not burn as easily as any type of cable, and they will not also emit toxic gases, because given that all the cables are supposed to pass within the ventilation area or in the plenum of a building, they don't need that the gases from those cables should go to the ventilation and intoxicate the whole building. So when a cable is said to be plenum rated, it means that cable is capable of working very well in the plenum of a building, the plenum area of a building, and is immune to fire outbreaks, for instance. Okay, is that
Okay.
understood?
Yes, sir.
Right. Any other question?
No, sir.
So I believe that should be it. Sidan, do you have a question? Okay, that should be a no. So let's call it a day and see you guys on Sunday. Let's just be early. See you guys on Sunday. We're definitely going to be like 2 hours into Sunday so we can cover the rest of chapter 5. This is red. Red. You can even read.
Nothing for now, sir.
Okay, you can even read beforehand what red is all about. I'll put the slide in the group. You guys should go through it and see you all on Sunday. Have a great weekend.
Thank you, sir. Same to you.
Thank you.